Okay, so in this video, what we're going to be looking at is Boxplots, as the title suggests, and we're going to go through a couple of different things to do with Boxplots. All right, let's start off. The Boxplot is constructed from the values in a 5-number summary. And just in case you haven't heard, in case you don't know what a 5-number summary is, it's the minimum value, it's the Q1, it's the median, otherwise known as Q2, Q3, and the maximum value. That's my 5-number summary. Okay, so let's actually write that here. 5-number, oh, I can't even write properly. 5-number summary. Okay, so just to keep that in mind about what it is. Now, I'm just going to use this one, even though there's one down here. I'm just going to use this one because I think this is a nice little one to use to highlight key points. Every box plot has this shape. Okay, it has the median there. It has a whisker. Sometimes generally you often have a thing like on the end there. So it's good to put that in. Okay. And so, oops, so you got your whisker. Okay, now what's really important is the whisker represents 25% of your data. From Q1 to the median, that's another 25% of your data. From the median to Q3, another 25% of your data. And that final whisker is another 25% of your data. The reason I'm sort of emphasizing that is because it doesn't matter if your box plot looks like this, for example. It doesn't matter if it looks like that, for example. Okay, that is still 25, that's 25. That's 25, that's 25, 25, 25, and 25, and 25. Okay? What this is suggesting, in other words, is spread is different here. Because your spread's a lot bigger here. In this case, because I draw them so close, the range is pretty, this one's got a bit of a bigger range, but not significantly so. The median's roughly in the same spot, but one's got a huge range. So the spread of data, so 50% of your data's here, and 50% of your data is in that block there. That's what the box plot represents. Okay. I know this is just talking about the distribution in this top bit. It's about symmetric. We'll go through that in a little bit. But yeah, so symmetric is basically if it looks symmetric there, negatively skewed. If that box plot is more to the right and positively skewed is if the main box part of here is to your left. Okay, but we'll go into a bit more detail on that in a little bit. Okay, so we've talked about that. That's representing 50% IQR. So remember, this is your IQR. Okay, that's our 5-number summary. Okay, and you can work out. You can just draw it from that. You don't need anything else other than that to draw your box plot. So if you get a bunch of data and you've got calculate instructions like this part here, drawing box plots or finding the 5-number summary, you can do drawing them like this. So I've got another page where I'm going to show you some instructions as well. But you can get that 5-number summary, and you're going to go for this one, this one, this one, this one, and this one. Those are the 5 you're after, and that gives you your 5-figure summary, 5-number summary, and we'll talk about these other 2 later on. Okay. So outliers very important because they can sort of skew what your data and what you're looking at. How do we calculate them? How do we check for them? You've got to always got to do an outlier check because you don't know unless you look at your data. And usually it's something. And a perfect example is this: if say for myself, I'm 194 centimeters tall, and I'm doing a thing of heights in a Year 7 class. Now, most Year 7 classes, kids are going to be about between 150 and 160, maybe 170 centimeters tall. But if I put my height, or a kid of my height in there, he or she will skew the data. So we want to look at where the majority of those students are. We want to check if that person's an outlier. They're most likely going to be an outlier if they're nearly 2 meters tall. Okay, and how do we check that? Well, we look at our data and we find what our IQR is. Okay, so we need our IQR to do this bit. All right, and then if we want to find the lower part, okay, we're going to do this. We're going to go Q1, so that's our Q1 here, or whatever your value is. We're going to subtract 1.5 times our IQR. So the IQR in this case here is 5. We're going to go Q1, 3 minus 1.5 times 5, so 7.5. So we're not going to have any outliers here. Okay, this one, and well, this is what we've done here. We've done there. Q3, we're going to look at Q3, do it down here, go Q3, okay, plus 1.5 times 5, so that gives us 15.5, and that's where we're saying 15.5 is here, okay? And that's what I'm saying if you had to, I was just looking at the previous data. So 16, I've added 16 to give you a bit of a trial of this. Okay, so the idea here is you're looking for these lower ends and upper ends. Okay, and they're like little, you've got to imagine them, is they're like these little fences there. This fence would be in the negatives, but it would be down here. Okay, so if I have a number on that side of the fence, it's an outlier. If I have a number on that side of the fence, it's an outlier. Okay, in whatever data you've got. Okay, and that's just a nice one to show. I would think about putting something like this along with the outlier equations into your summary book. That's a nice thing. It's got the 25% of your data point. Just remember, these box plots can also be drawn to look like something like that. Okay, means the same thing. 25, 25, 25, 25. Okay, so drawing box plots, you can use your calculator to do that. There's instructions you showed before. There's also these instructions. These are in the OneNote, so don't worry too much about if you can't see it right now. So I'm going to move on. This is where I was talking about the representation of box plots and histograms, and what the skew is and how it sort of looks. So we can sort of approximate if we've got a symmetric. Okay, we can see that most, everything's sort of relatively well symmetric across each side. The box inside doesn't, it can be a bit wider, it can be thin, but it's symmetric across here, here, and here, and here. Okay, that's where I said the whiskers are approximately equal in length. Positively skewed, as I said earlier, most of this data is down the left-hand side more so it trails off. That's why we get the positive skew. And this one we get the negative skew for some reason, because this data is up that more positive end. Okay, so distributions with outliers are characterized by gaps between the main bottom data. So that's where I got my, and sorry, I forgot to mention it. I'll go back in a moment how we draw outliers. The histogram opposite in this one displays a distribution with an outlier. So this is represent the main body of the data. This is representing our dot. That's how we represent an outlier. I should have been a bit more explicit with that. Back here, we represent this outlier. However many outliers I have, we represent them by dots. That's how we represent them. Okay. Now, so this is an important one to compare. Okay. So So this is looking at some investigate relationship between numerical variables, salary, so how much people are earning, and age groups. They've got a bunch of age groups there. So we've got that information. We've put it into, for each of those age groups, we've got a thing that looks like this. Okay. So this is sort of getting into a bit of more of the bivariate in the sense of I've got two variables. I've got a numerical and I've got a categorical. That categorical one is going to be the salary, and our age. This here, in this case here, is our independent. So that's our independent being the explanatory and the dependent being the response. If we look at things in when we get to regression type stuff later. So what you're looking at, it's about displaying the relationship between numerical variables and the categorical variables, and this is giving us things. So what we can see here, we've got some outliers, okay, in those sort of older age groups, the salary and the age, sort of suggesting that, you know, as you, just as a general thing, as you get older, your median salary increases, although there's probably not a lot of change between these two. What you do probably see is a much bigger spread as we're going. Things start to really spread out across the whole of the box plot. In these ones here, you're seeing more of a spread in the middle 50%. And you also see in the start to see these bigger values come out here. Okay, and so what we can look at, if we're comparing medians, we can see from the parallel box plots, we can see the median salaries increase with age group. So from 24,000 for 20 to 29 year olds to around 32,000 for 50 to 65 year olds. And it's an indication that typical salaries are related to age group. Okay, that's how you could write it. Another way to write IQRs and ranges. From the parallel box plots, we can see that the spread of salaries increased with age. So the IQR increased from 12,000 for 20 to 29 year olds to around 20,000 for 50 to 65 year olds. So looking at this point here, okay, and this indication that spread of salaries is related to age group. If you look at the shapes, I didn't talk about that before. The shape of distribution changes, so approximately symmetric here, okay, and becomes progressively more positively skewed. So this is quite positively skewed here at that 50 to 65. And there are different ways to actually describe the data. Okay, so that's sort of the theory done. So what I wanted to show you here is an exam question, or exam style question, which is using these box plots. So you're comparing two box plots and giving you some questions to work through. Okay, so here's a question. It says, the box plots below display the distribution of maximum daily temperatures for the months of May and July. Now, I'm going to be very specific and talk about some stuff up top about what you need to do here. So what's important in these types of questions, and you'll see these quite often, is they're saying that, you know, as you go across, that's the representation of the different temperatures throughout July and throughout May. And so it's not saying that this is in the middle of July or this is in the middle of May. It's saying from the first day of July and the last day of July, this was the median temperature. So the median temperature was about 9 degrees. Okay. This one here, the middle temperature was 14.5 degrees. If I read that right. Okay. So that's what you've got to look at. That's how you have to sort of interpret these types of questions. It's representing. That's why it's representing that maximum daily temperature as is associated with that particular month, because it's saying that those are the spread of temperatures throughout the month. It's not saying which day is giving you which temperature. It's saying the spread and the range of temperatures. And that's important for that question there. Okay. So question 1, describe the shapes of distributions of daily temperature. So what you're looking at here, and you've got to be very specific. You're going to say for July, you'd say positively skewed, because remember this is sort of, it's pushing over to the left-hand side and the data's in a sense trailing off. So you'd say positively skewed, but what does it also have? It has an outlier. So you need to say positively skewed with an outlier. This one here, from what you can see, you would say that it's approximately symmetric. And my approximately symmetric drawings are pretty bad. Okay, so this doesn't have to be, sort of really, sort of like that small in the middle. It can be as big as small as it needs to be, but everything's approximately symmetric. Okay, so you need to say approximately symmetric. If you mention skew, you're not going to get an answer. If you say slightly symmetric, you're probably not going to get an answer either. You'd have to be fairly specific and be saying approximately symmetric. Okay, and to get that mark, you need to have both answers correct. Get one of them wrong, you lose the mark. And question 2, determine the value of the upper fence plotted for the July box plot. So July, you're going to be looking at your IQR, and your IQR is going to be going from 11, so it's 11 to 8, so it's going to be 3, so your IQR is 11 minus 3, giving you 8. What did I say that? I said the wrong way. 8, and that's 3. Oops. Okay, and now we're going to do upper fence. So that's going to be 11, because that's our Q3, plus 1.5 times 3. That'll give you 15.5. And so because you upper fence, you have to be very specific. You have to say that upper fence is 15.5 degrees Celsius. Remember to do things like that throughout your exams. It has to be that exact value. Now, this is the one where I was being very pedantic about what I was trying to say at the top. And that's how so if you have any issues, come and see me again and I'll go through it with you. All right. So this one here, the best way to talk about it is in terms of the medians. So you'd be wanting to reference it. So the maximum temperature median for May is 14.5, and you'd be saying July, the maximum temperature median is about 9 degrees. Okay, and that's how you're making that reference. You could probably look at also using IQR and how those two differ. So you've got to have in that answer, you have to talk about how do two values differ and what are the actual two values you're looking at. You can't look at range or average. Okay, so that's an example you can use for that style of question. Okay, thank you.